Good evening to our viewers. This is the demo for FloatChat by Team Pelagium, and it's our attempt at making ocean data published by ARGO Group a more accessible form of data to the masses who might not have the technical knowledge required to easily parse the data. So let's get started. We hit New Chat. After creating a new chat space, we can message the AI agent present in the backend about anything that concerns us. It might be latest news, it might be the history of ARGO group, general knowledge, and of course the data itself. So let's start simply by making some small talk. I can send it a simple hi. After sending hi, it responds to me with a hello and also offers help regarding the ARGO data. One thing to note is that if someone messages anything that does not correlate with the ARGO data and it's an entirely different topic, the AI agent would reply that the query does not fall in its responsibilities and would decline to help. The AI agent operates on primarily three modes. It has a base mode where it replies to the user with the knowledge it already has, the knowledge that it has gained from the training data. It has a web search mode where it tries to retrieve information from the web that might be relevant for answering the query provided by the user. And there's an analyzer mode where the AI agent retrieves data from the backend and analyzes the data in both textual and also visualizes the data and generates an entire report and provides it to the user. So let's start by just trying out the basic mode. I can just ask it about the history of ARGO and the timeline about it. As we can see, the AI agent has analyzed our query and provided an appropriate response to our query. So let's move on to the web search mode. Since we are talking about the web search agent, why do we need the web search mode at all? The AI agent already has information regarding the ARGO group and its history, so why need it at all? The problem lies within the AI models used for the AI agent. The AI models can only provide information which has been included in their training data, and now this training data might include data from maybe 6 months ago, maybe 1 year ago, or maybe more than that, but it won't possibly include data that's been uploaded to the internet or may be available to the public over the last 1 week or last 1 month. These queries are influenced by time, these things change over time. So, we need a web search mode which allows the AI agent to conduct web searches and retrieve the most recent data available to provide accurate and helpful answers. As we can see, our prompt got analyzed by the AI agent and it determined that it needs to conduct a web search. So it conducts a web search, it finds the most recent article published by the ARGO group, retrieves the information from the article, and then provides to us the short summary of the article. It unfortunately does not provide the link itself as of now. We plan to include it in the future. Well, that concludes our functionality for the research mode, and now we will move on to the penultimate mode, which is the analyzer mode. Analyzer mode is essentially the heart of the project, as it is the primary condition provided to us by the problem statement, which is to make the ARGO ocean data accessible. Now let's discuss how the analyzer mode works. So, first of all, after receiving our query, the AI agent determines if analyzer mode is to be invoked. If it decides so, the user's query as well as the SQL schema of the database both are passed to the SQL coder AI agent, which then writes an SQL query to retrieve information from the database based on the provided inputs, visualization agent, as well as another textual analysis agent. They determine which is the best possible analysis method that can be provided to the user. Both of these agents write particular code. These codes are run in a sandbox environment and then the output is returned back to the main thread of the program. So for demonstration, let's start with the most basic of the queries, that is average salinity year-wise. As we can see, our query got analyzed, the database retrieved information, and the visualization agents, the SQL coder agent, the textual analysis agent, everyone did their job and it finally provided us an appropriate response for the query. Let's try a much more complicated one, which is the salinity along with PSU changes across the years. As we can see, the analyzer mode works as it is intended to work as of now. There are multiple improvements that can be made and that will be made soon. And before ending the video, I'd like to discuss a few things that we have also used in this project that I'd like to bring to the notice of the viewers. So first of all, I would like to say that there has been extensive use of server-sent events in our project. As we can see, after making a query, the front end shows analyzing the query or retrieving database or plotting the map or anything back end events being reflected into the front end. What it does is simply a better experience for the users. Our backend procedures can take a lot of time. It can take up to 25 seconds for the analyzer mode. So a static piece of text on the screen would be very boring and very undeterministic. So servers and events in our project make the interaction extremely interactive. And also one could see that when the AI agent replies to the user, the entire text does not appear instantly as a single piece of information. It does appear word by word, which is also a much better visual experience. This is the first point, which is servers and events. And the second thing that I'd like to talk about is the AI models that we have used in the program. For the base model of the AI agent, the reasoning model, that is done by O4 Mini since it's a reasoning model. The coding models, which are SQL coder, visualizing agent, and the analyzer agent, all three of these are using Claude 4 Sonnet in their backend, since Claude is a excellent model for coding purposes. That's all for additional notes behind our project. As a conclusion, I would like to request the reviewers to try out our demo. The link is provided in the presentation, last slide. The version is the same as our version that was presented during the college internal hackathons. Our GitHub link was also present. All our development is regularly uploaded there. The most recent working model, the working demo, would be highlighted in the README file of the main branch. Please, if there's any new updates, please check it out. Thank you.